So now we'll be discussing question number 20 from phase 1, chapter forces and laws of motion. This is from exercise 1. Let's read it. So a lift of mass 2000 kg. The mass of the lift is 2000 kg. It is supported by thick steel rope. If maximum upward acceleration of the lift is 1.2 meter per second square. The maximum acceleration of the lift is given as 1.2 meter per second square. And the braking stress of the rope is 2.8 into 10 to the power 8 Newton per meter square. So braking stress means the moment stress goes beyond that, the rope will break. Now, when it comes to the stress, the formula is sigma is equals to F by A. The force divided by the cross-section area gives you the stress. This is the normal stress. So maximum stress will be corresponding to the maximum force. In case of steel rope, the force will be in the format of tension. So maximum tension divided by area will be the maximum braking stress. So this sigma is given. Since sigma is given, so ultimately indirectly they have given the maximum tension which this rope can handle. So T max, maximum tension, comes out to be 2.8 into 10 to the power 8, which is the braking stress multiplied by the area. What would be the minimum diameter of the rope? So they are asking about the minimum diameter of the ropes. The area of the rope, basically, you can define in terms of diameter. That will be pi d square upon 4. So the area is pi r square and the r is d by 2, diameter by 2. So the minimum area will be corresponding to minimum diameter. So to calculate minimum area, you need to calculate maximum stress. Now let's focus on the stress. So I'll make the FBD of the lift. If I make the FBD of the lift, the mg is acting downward for the lift. Tension will be acting in upward direction and the acceleration is in upward direction. Since acceleration is upward direction, so upward forces will be positive, downward will be negative. So my equation will be T minus mg is equals to m into a. If I want maximum acceleration, I will be having maximum tension. So T max becomes mg plus m a max, or you can say mass multiplied with the g, which is 9.8 plus a max is 1.2. So here I'm taking the value of g as 9.8. Why I'm taking it? Because the acceleration they have given as 1.2. That's a hint, indirect hint. So this whole value becomes 11 times of m. That is the maximum tension. This value I'll be putting here in this equation. So 11 multiplied with m, which is 2000, is equals to 2.8 into 10 to the power 8 into area, and area from here we can get, which is pi into d square by 4, or d square will be equals to 4 into 11 into 2000 divided by 2.8 into 10 to the power 8 into pi. When you calculate this, it will be coming out to be 10 to the power minus 2 meters. Sorry, 10 to the power minus 4 meters. And the diameter will be coming out to be 10 to the power minus 2 meters. So in this case, they were talking about the maximum stress. The thing is, if I'm moving this lift more than the acceleration, which is 1.2, the tension will be more than the T max. If the tension is more than T max, then the sigma is more than sigma max, and this rope will break. In real life scenario, this is how the calculation is done. Whatever rope you use in case of lift, for every rope, there is a maximum stress. So the acceleration of the lift is decided by the rope which you are using. So there are some fast lifts are there and there are some slow lifts are there. The difference in the slow lift and the fast lift will be based upon what kind of ropes are used to move the lift up and down. Okay. So this is how the calculation is done. Thank you.